Hello, my dear students. Raman Rana here, your mathematics teacher, Cambridge International School, Dasuga. Today, we will take the same chapter, triangles, and we will move ahead with basic proportionality theorem and its converse. Dear students, yesterday we have started the topic triangles and we have studied about congruent triangles. We have studied about the similar triangles. So in grade 10 syllabus, the very first theorem is BPT. We have understood what is the basic proportionality theorem, which is popularly known as your Thales theorem, on the name of the mathematician Thales. He was a very popular Greek mathematician. So let's recapitulate what is similarity. So triangle A, B, C is said to be similar to any other triangle D, E, F. Two triangles are said to be similar if we have two conditions. What are these conditions? First one, their corresponding angles should be equal. Their corresponding angles of one triangle should be equal to the corresponding angles of the another. First condition means angle A is equal to angle D. If two triangles are similar, then confirmed angle A is equal to angle D. Angle B should be equal to angle E, and the third angle C is always equal to angle F. So first condition is that corresponding angles of these two triangles are always of same measure, equal. Now the second condition, that the ratio of the corresponding sides is always equal. The ratio of corresponding sides. What are the corresponding sides? If we are taking first side AB here, so here AB upon DE is equal to the second side, that BC upon EF is equal to the third side, that is AC upon DF. So second condition is the ratio of the corresponding sides. Corresponding sides are in same ratio, which says that side AB upon DE is always equal to the second side BC upon EF, which is further equal to the third side of a triangle, that is AC upon DF. So this is the condition that three corresponding angles should be equal and the ratio of the corresponding sides should be same. Then these two triangles are similar, or if two triangles are similar, then these relations will always exist. We have further discussed in detail the basic proportionality theorem, which was popularly known as the Thales theorem. BPT, basic proportionality theorem. Dear students, it is very important theorem, and most of the time it is coming 4 marks in the exam. So sometimes examiner is asking its statement, or sometimes the examiner is asking state and prove Thales theorem, or state and prove basic proportionality theorem. So we have studied in detail. Let's recapitulate again what this BPT says. First, its statement. It says that if any line is drawn parallel to any one side of triangle, if any triangle is there, like this is a side AB and ABC is a triangle in such a way that any line, if any line which is drawn parallel to the side here, let this is line L, and this point here is D and E. Let's come to the statement of the BPT. If any line drawn parallel to any one side of a triangle bisects the other two sides at two distinct points, divide the other two sides in a fixed ratio. If according to BPT, we have to prove that AD upon DB is always equal to AE upon EC. This is the statement of basic proportionality theorem. So how to prove it? Just in three equations we have took it. We have taken triangle ADE. After taking this triangle ADE, we have drawn altitude on the respective these sides AD and AE. On AE, we have drawn 190 degree, or you can say altitude on it, and we have named here this point as point M. DM is the altitude on AE. Similarly, from this point also we have drawn one more altitude or perpendicular, and we have named it as point N here. So our first equation, what we have done here, the area of triangle in two ways. Area of triangle ADE, we know area is half when we are taking the base AD, then its corresponding altitude is EN, and if we are going the same triangle, its area can also be written as half into AE multiplied by AE multiplied by the corresponding altitude is sorry, here it is EM, no, it is DM, sorry, it is EN, it is your EN, and here half into AE DN. So I am talking about the same triangle ADE. Its area is half into base into height. Now base is AD here, corresponding height is EN. EN is the corresponding height, and when base of the triangle is AE, the corresponding altitude is DM. This is DM. Now let's start. Where here we want to prove AD upon DB is equal to AE upon EC. How to come at the first equation? Here we have ratio of area of a triangle ADE upon area of a triangle. Here join B with E. BDE. Triangle BDE. Here area is half, its base is AD, and the altitude is EN. Whereas its area is half, base for this side is DB into altitude is same. Here EN cancelled, half cancelled, and we have left with AD upon DB. This is equation number 1. Similarly, Similarly, area of a triangle ADE upon area of a triangle, here we will take the triangle CDE or CED, its area is also half, side is AE, corresponding altitude is DM here, and here also half into the side, that is respective base here is EC. We can check it from here, this statement of the BPD. We want to prove these sides, ratio of these sides. So here corresponding altitude, if DEC, EC is the base, altitude is DM. So we get half with half. The second equation AE upon EC. Take this is equation number 2. Now third, we have discussed in detail that these two triangles, that here triangle BDE and CED, these two triangles lie on the same base. Base is here DE. Base is here, D is the common base and lies between the two parallels. Here in BPT it is given that DE is always parallel to BC. So dear students, we can write on that area of triangle BDC is always equal to area of triangle CED. And what is the reason here? Triangles on same base and between same parallels. So here right hand side, left hand sides, numerator they are equal, triangle they are equal, and here with third equation we are equating these two triangles BCD and CED. Like this is equation number 3. So from 1, 2 and 3, from equation 1, 2 and 3, from equation 1, 2 and 3, we have proved that AD upon DB is equal to AE upon EC. So dear students, this is the proof of your basic proportionality theorem. Now next theorem, that is theorem 10.2 in the book, given in the book, theorem 6.2. Theorem 6.1 is BPD, 6.2 theorem is its converse. In its converse, if in a triangle, any triangle, if the ratio of the sides, like P, Q, R is given, and like these 2 points are X and Y, such a way that Px upon XQ is given equal to Py, this point is Y here, upon YR, then we can prove that the line XY is parallel to QR. So we will discuss in detail today the converse of BPT and how to prove it. So what is the statement of the converse of BPT? Here we have given this line is given parallel to the third side, that is BC. But here we want to prove this side here, that XY parallel to. So here this statement is given and we want to prove that XY is parallel to your side QR. So this is the converse of BPT, basic proportionality theorem. Theorem 6.2, if any line divides the two sides of a triangle in a in a same ratio, then that line is always parallel to the third side. Let's take one triangle here. Converse of BPT we are proving ABC is a triangle, and draw a line here such that these points are D, and one point is D here and another is E here. Now what is given? Given here, start the proof of the theorem. Proof given here that AD upon DE is equal to AE upon EC. Here we have given that AD upon DB is equal to AE upon, that is DB. It is DB here is equal to AE upon EC. Now to prove, we want to prove here that DE is parallel to BC. Always this line BE is always, this DE line is parallel to BC. So how to prove it? If by contradiction we will move, but if DE dash, like E is a point here, let's suppose E dash is a point, and here this is the one line, and here if E dash is another point, E dash is another point, such that if DE is parallel to BC. Suppose DE dash is parallel to BC. Then what BPT says? BPT says that your AD upon DB is equal to AE dash upon E dash C. But what we have given? We have given AD upon DB is equal to AE upon EC. That is equation number 1. And we have gone for E dash. If there is E dash any point which is such that DE dash is parallel to BC, then BPT will apply. Like this is equation number 2 here. From 1 and 2, from equation 1 and 2, we have AE upon EC is equal to AE dash upon E dash C. Here it is very important to understand, because in your textbook here it is given Y, and further in one more step they are saying Y. Here one thing they are using, adding both side 1. This is left hand side, right hand side. If we are adding 1 both sides, the equations remains the same. By adding 1 both side, we will get denominator, we will get EC, and here AE plus EC is equal to, again this side E dash C and E dash E plus E dash C. So in both the cases we have AE upon EC plus EC is AC upon EC is equal to, here also, E dash C. So we get 1 upon EC is equal to 1 upon E dash C. So reciprocal, taking reciprocal, we have EC is equal to E dash C. So reciprocal is also equal. So we have EC is equal to E dash C. So this implies that E and E dash both point must coincide. Both points must coincide. Both points must coincide. We don't have any 2 points. There will be a 1 point which is here, which is so that the DE is always parallel to BC. So this is the proof of this theorem 6.2 theorem. Now I hope you are very much clear with these two theorems. We have a few examples. Let's start with the very first example here, example number 1. Example number 1, your textbook. It says that if ABC is a triangle, and a line DE is parallel to BC. Same statement like BC. What is given here? Given DE is parallel to BC and BPT says AD upon DB is equal to AE upon EC. But here they are asking something different. They are asking here, prove that AD to prove. Example 1, they are asking that AD upon AB is equal to AE upon your AC. So I will discuss in detail the other concepts here by BPT. Basic proportionality theorem says that if DE is parallel to BC, then AD upon DB is equal to AE upon EC. So here we want to prove here AD upon AB and AE upon AC. So by BPT, by basic proportionality theorem, we have AD upon DB is equal to AE upon EC. Now we want AB, so we can take their reciprocal first. By taking reciprocal, DB upon AD is equal to EC upon AE. Because we want to go for AD. So now adding one both sides, the equation remains the same. Left hand side 1 and 1 both side. Now LCM is AD and here AD plus DB is equal to AE EC plus AE. So here this is further equal to AB upon AD is equal to AC upon AE. Now again taking the reciprocal, that is AD upon AB is equal to AE upon AC. So this is the example number 1. So we want AD upon AB is equal to AE upon AC. Example number 2 says that if ABCD is a trapezium, example 2, if AB here A, B, C, D is a trapezium, and EF, E and F are the 2 points on the non-parallel sides AD and BC in such a way that EF is parallel to the sides AB and DC. So here what is given, that ABC is a trapezium, ABCD is a trapezium, means AB is parallel to DC and E and F are the points on the non-parallel sides AD and BC here, in such a way that EF is also parallel to the side DC and AB. Now to prove, you can check your books. To prove, AE upon ED is equal to BF upon FC. We want to prove. So I hope you understood the question. ABCD is a trapezium and E and F are the points on the non-parallel sides such a way that EF is parallel to DC, and further we know AB is also parallel to your EF. And we want to prove that AE upon ED is equal to BF upon FC. So how to prove it? We have to go for one construction. Join A with C. Join point A with C such a way that this point is point G. Now we will apply basic proportionality theorem here in triangle ADC. AG is parallel to DC. So here EG is parallel to your DC. So by basic proportionality theorem we can write AE upon ED is always equal to AG upon GC. This is like equation number 1. And what is the logic here? Basic proportionality theorem says. Now here go ahead for triangle ABC. ABC, GF is parallel to AB already. So here GF is also parallel to AB because it is given. So we have AG upon GC is equal to BF upon FC. Let this is equation number 2. Again the logic is basic proportionality theorem. So from equation 1 and 2, we have from equation 1 and 2 we have AE upon ED is always equal to BF upon FC. AE upon ED is equal to BF upon FC. So I hope with the help of BPT we have proved very easily that AE upon ED is equal to BF upon FC. Now go for example number 3. Look at your books. In example number 3 we have a triangle PQR. We have one triangle PQR. P, Q and R, and there is a line drawn ST in such a way that angle, it is given here that angle PST, given here angle SPST is equal to angle PRQ. Given here, it is given that PS upon SQ is equal to PT upon TR. So this is given that angle S is equal to R, PST angle and PRQ angle, they are equal, and this one, the ratio PS upon SQ is equal to PT upon TR. So here we have to prove that triangle PQR is an isosceles triangle. It is an isosceles triangle. So, dear students, we know if PS upon SQ and PT upon TR, this statement is given. So, by converse of BPT, we have ST is parallel to QR. This is the simple explanation. Here PS upon SQ is equal to PT upon TR. Then by converse of BPT, we have ST is parallel to QR. Now if ST is parallel to QR, then we have angle PST is equal to angle PQR. So here already we have given that angle, that this is equation number 1, and we have given angle PST is equal to angle PRQ. Here we will give the logic corresponding angles, and here this is given here. PST is equal to angle PQR. PST and PQR, these are corresponding angles because we have proved ST is parallel to QR. So I hope you got it from 1 and 2. From equation 1 and 2, we have angle PQR is equal to angle PRQ. So in a triangle, if two angles are equal, therefore triangle PQR is an isosceles triangle. So dear students, I have taken all the examples before exercise 6.2, and I hope this concept of BPT and its converse is very clear. We have 10 questions in exercise 6.2. Go ahead with these questions by applying the knowledge of these two theorems, and I am very much sure that you can solve all these questions. So tomorrow we will take the exercise 6.2. Those were the hot questions there, or little tricky questions, and after this we will start the next topic, that is the criteria of similar triangles, criteria for similarity. In this topic, this chapter triangles, we have left with the similarity criteria. Then we have a very important theorem with the ratio of the area of the two triangles, and the last one is the Pythagoras theorem, or the properties of Pythagoras theorem. So dear students, thank you very much. Stay safe, stay healthy.